This problem is from the section 2.10, the law of total probability and Bayes rule. This is the problem number 2.124. A population of voters contains 40% Republicans and 60% Democrats. It is reported that 30% of the Republicans and 70% of the Democrats favor an election issue. A person chosen at random from this population is found to favor the issue in question. Find the conditional probability that this person is a Democrat. First, understand the major sets. How many sets we have? Two sets. Those are Republican and Democrat. So, what is the percentage of Republican? That is 40%, right? It is 40%. And Democrat, 60%. So, I write down probability of Republican is 0.4. Probability of Democrat is 0.6. Then, next sentence. It is reported that 30% of the Republicans and 70% of the Democrats favor an election issue. Okay, 30% of the Republicans. That means we already know this 30% coming from the Republican, right? We already know they are Republican and they favor. This is the 30%, right? So, that is the conditional probability. What is the probability? Probability of favor. Therefore, probability of favor, but we already know this group coming from the Republican. Republican should be the conditional, right? So this is 0.3. Similarly, 40%, no, this is 70%. 70% coming from the Democrat, right? So we already know that they are coming from the Democrat and they favor, probability of favor, but coming from the Democrat, that is 0.7. Right, now question is this. Find the conditional probability that this person is a Democrat. Right, now we need to find the conditional, okay, we say just probability that this person is Democrat. And then we need the Democrat probability, right? But we do have a condition. What is the condition? Look at here. A person chosen at random from this population is found to favor the issue in question. We already know a person, we already get a person at a random, right, from this population is found to favor the issue in question. We already know he is coming from the favor group, right? It means we already know this favor here, Democrat and also Republican both are here, right, in this group. So now we know we pick one randomly from this group. Okay, therefore this is we already know it is a favor group, right? So then asking probability of what is the probability this person person is a Democrat, right? Person is a Democrat, right? So therefore we can write this one. What is the equation we write? Probability D and F divided by probability of F. So this is the equation for the conditional probability. Now we need to find the probability of D and F. How do we find the probability of D and F? Right. Probability of D and F is not given. Here we have probability of R, D, F given R, F given D. So we can write probability of F given D. Why? Because we have this one here. You see that. That's why I use that part. This equal probability of D and F divided by probability of D. From this equation, we can have probability of D and F equal probability of D time probability of F given D. Yes. Now we know probability of D, it is 0.6, probability of F given D. So we can find the probability of D and F. Yes. Now how about probability of F? Probability of F. Now again think about this. There are two groups R and D, and F favor are in the both group, right? But R and D are disjoint. There are no any common element, right? Nobody like both Republican and Democrat, right? Or, maybe Republican and maybe Democrat, right? So therefore we can write probability of F equal probability of Democrat and favor plus probability of Republican and F. Actually, this is first, if you didn't understand, I can show you over here. This is the case. Probability, okay, we can say favor group equal R intersection F, because they have one also favor people, right? And union D intersection F. Then probability of F equal probability of R and F union D and F, like this. But you know Republican and Democrat are disjoint, therefore R and F set and D and F, these two sets are also disjoint. Therefore we can write probability of here D and F plus probability of R and F. So what happened to the minus part? So minus part is probability D and F intersection, because here union, therefore intersection R and F. So you see, so these two are disjoint, so this probability should be 0. So that's why we didn't write that part here, right? So then actually we know probability of D and F and probability of R and F. So probability of D and F, you see we have already here. So we can write probability of D times probability of F given D. Similarly, you can write probability of R times probability of F given R. Okay, right. Now we can use probability of D given F equal probability of D and F. So what is the probability of D and F? You see probability of D and F equal this, right? Probability of D times probability of F given D, and divided by probability of F equal probability of D times probability of F given D plus probability of R times probability of F given R. So we know all the values. Probability of D equal 0.6, probability of F given D equal 0.7, divided by again 0.6 and 0.7 plus probability of R equal 0.4 and probability of F given R equal 0.3. Simplify this, you can get this is 7/9. This is the probability, actually conditional probability of Democrat given that is a favor, right? Let me explain same example using a tree diagram. Okay, again, how many sets, major set we have? We have two major sets, right? Therefore, tree diagram first start using two trees. Okay, this one Republican and Democrat. What is the probability of Republican? It is 0.4, and probability of Democrat, it is 0.6. Yes, it must be 0.6 because 0.6 plus 0.4 equal 1. Right. Then in the Republican group, there are two groups, favor and not favor. Similarly, in this group also favor and no favor. So favor, right? Favor. So what is the probability of favor given of the Republican? That is 0.3. Therefore, this must be 0.7. What is the probability of favor of the Democrat? It is 0.7. So this is 0.3. Now we can write the probabilities. Let me show you. I write this here 0.4 multiplied by 0.3, and this one 0.4 multiplied by 0.7, this 0.6 times 0.7, and the last 0.6 times 0.3. Okay, what are these probabilities? Here, this probability is probability R and F. This is probability of R and N. This is probability of D and F. This one is probability of D and N. So what is this then? That is the probability F given R. Similarly, this probability of N given R, this probability of F given D, and this is probability of N given D. So you see then this should be probability of D, right? You know already, but I just explained to understand the pattern. You see this is probability of R. So you know all the probabilities for this base rule. So then you can plug the numbers and get the answer.